Hey, what's up guys? This video is for section 7.5, which is graphing exponential functions, and this is part 2. So if you guys haven't seen my first video, it's really important that you guys understand the vocabulary that I'm going to use. You guys can see some on the screen: transformations, domain range, asymptotes, and also I'm going to talk about the two kind of exponentials that we have. So once again, if you guys haven't seen my first video, go ahead and do that right now. Watch part 1, and then you guys can come back to this one, and we're going to continue graphing exponential functions when you guys have a transformation. So let's go ahead and look at the next example. So here's the next example. You guys have f of x equals 3 to the x power minus 2. So we have the base 3, exponent is x, and we do have a minus 2. Notice that we have a number after the base with the exponent. So that means that this here is a transformation for the parent function. If you guys don't have any numbers that changes the actual graph, that's called the parent function. But here we have a transformation. So we have to understand what the numbers mean. First of all, we look at the base. So I know that my base, and I'm just going to highlight the base, is 3. Since the base with the exponent is more than 1, so my base is greater than 1, my function will be growth. So my graph is going to go from left to right. So I'm going to start from the left side of the graph. I'm going to go to the right, and it's going to increase, going obviously up. So that means exponential growth. One more time, from the left goes to the right, and it increases. The asymptote is the line that the graph approaches but never touches. For that, we need the k-value. And the k-value is the number after the base with the exponent. So here is your k-value. K is -2. Now let me show you guys the general function when you guys have a transformation. So the formula, and you see the formula up here, you guys have the a before the b, you have an h after the x if you have a transformation, and the k-value is at the end of the function. So that's my k-value. So what that means is my asymptote, the line that the graph approaches but never touches, is going to be at y equals, and I'm going to write down my k-value, and my k-value is -2. So the asymptote is not on top of the x-axis like before, because now we have that asymptote at -2. So on the y-axis, you're going to go to your -2, which is here, and you're going to make an horizontal dashed line, and I'm going to make that right now. And you see the graph dash line at -2 on the y-axis. So my graph is going to get closer and closer to the asymptote, but it's never going to touch. Notice that the asymptote was moved. It's not on the x-axis like before. Now it's down to the -2 power. So the next step is to find 2 points that are going to help us graph the actual curve, the exponential function. Now this is where you guys have to understand what the function means. Notice that the general function, when there's a transformation, you can have a number in front of the base, you can have a number after the x, and you can have a number at the end of the function. Now this one, we don't have a number after the x, like in the exponent portion, we just have an x, so here's the x, but we do have a number at the end of the function. In front of the base, we don't have an actual number that you can see, but we say we have an invisible 1 for the a value. Now when a value is 1, it's not going to make a lot of difference, but just keep in mind that you guys can say there's an invisible 1. If you have another type of transformation, so here we do have a k-value, so it's a transformation. I want you guys to find the 2 points by ignoring the k-value. So we are going to use this equation, y equals the a value times the base to the x exponent. Now remember that a is an invisible 1 here because we don't see anything in front of the 3, but I am going to ignore the k-value, and I'm going to find the 2 points. After I find those 2 points, I'm going to translate, which means I'm going to transform what the k-value means. And this is going back to the definition of what is the k-value. And I'm going to tell you guys right now, the k-value is when you move the graph up or down on the coordinate plane. If it's negative, you move the graph down. If it's positive, you guys will move the graph up. Right now it's -2, so I am going to move the graph up. So I am going to move the graph down 2 steps. But this is what we do. We need to find 2 points first that's going to help us translate or transform the graph to a different place. So those are going to be my points of reference. We're not going to really use them to connect them, but I'm going to use them to find my actual graph. So I'm going to ignore the k value, and I'm going to put y equals 3 to the x power. So my a value is invisible 1. I don't need it. I just have the base to the x, no k value. I'm going to use 0 for my x value for the first point, and for my second point, I'm going to use 1. Notice that I'm leaving this one empty. It's going to be blank because sometimes it might change if you guys have an a value. So for now, I'm just going to leave it blank, and I'm going to leave this one blank as well because sometimes it changes when you have an a value. So once you guys substitute the 0 into the x and you find the y value, and then you substitute the 1 into the x and you find the other y value, you're going to plot the points. So let's go ahead and find those 2 y values. So I already plugged in, I substitute the exponents to be 0. So 0 goes into the x, just like right here. And a number to the 0 power is 1. So that's my first y value. And then I substitute a 1 here into the x. So this one goes into the x. And 3 to the first power is 3, which is the y value. So I'm going to plot those 2 points. I have 1 at 0, 1. So from the origin. Notice it says from the origin. 0, 1. So I make a point here. And my second point is 1, 3, right there. You're not going to connect those points because those are not your actual graph. You need to transform. You need to translate, to move those graph 2 steps down because we have a k value, and that's your transformation. So my first point, this one, I'm going to go 1 down, 2 down. So I'm going to make another point, a new point, right here. And my second point, which is this one, I'm going to go 2 steps down, 1, 2, and I make another point right there. Your graph, the actual transformation, is represented by the purple points right here. So I'm going to connect those points, making my exponential growth. So I'm going to start from the left side of the graph, close to the asymptote. I'm going to go to the right. Notice I'm doing my graph. I make a curve. I connect the purple points, and I go up because it is an exponential growth. The first set of points, we don't need them. You can actually erase them if you want. I don't mind if you have them on your graph, but I did not connect those 2 points because that's not my transformation. That's what is called the parent function. Notice here we don't have an a, h, or k. So it's just a basic parent function, and we transform the parent function 2 steps down. Now the y-intercept is when you substitute a 0 into the x value, but this is in your original function. So here's the x, this is the original function, 3 to the x power minus 2, and you guys have to solve for the y value. F of x is the same thing as y value. So I am going to substitute y equals 3 to the 0 power minus 2. So I'm going to put parentheses, and I'm saying my x is 0. So I'm going to simplify. Y equals 0. 3 to the 0 power is 1 minus 2. So y equals negative 1. So my y-intercept is at 0, negative 1. Notice that it's not the same point as this one because we have a transformation. Now the new y-intercept is at 0, negative 1. And you guys can confirm that on the graph. You see that it crosses at negative 1. So we got the right y-intercept. Now for the domain. Domain will be all real numbers. And every time you guys have a exponential function, the domain is all real numbers because every x value works for that function. Now the range is where you guys have to be careful. Notice that the asymptote is a negative 2 and my graph is above the asymptote. So what that means is for my range, I'm going to use y is greater than, and that's because the graph is above. If the graph was below the asymptote, then you guys use less than. But right now it's above the asymptote, so we use greater. And we use the k value of -2. Whatever the k value is, that's going to be a range. So I'm going to put -2 right here. So my range is y is greater than -2, and my domain is all real numbers. Now, what does it mean, guys? Okay, let me explain that. When you guys look at the graph, notice that no matter where you guys look at the graph, the y value will be always greater than -2. Nothing is going to be less than. Less than is below the asymptote. So my y value can be -1.9, -1.8. It can be -1. It can be 0. It can be 2, 4, 5, and it keeps going. So the y values will always be greater than -2. So let's go ahead and try this one here. You guys have the graph f of x equals 1/3 to the x power plus 4. First of all, let's go ahead and understand the problem, the actual function. So my base is 1/3. That is less than 1. So let me write that down. B is less than 1. Now mathematically, we say that b is in between 0 and 1. So I'm going to put it here. B is between 0 and 1. But if you say less than 1, I'm okay with that. What does it mean when the base is less than 1? It means that it's exponential decay. So my graph needs to decrease from up here. It's going to go down to the right. You always read the graph from left to right. So my exponential decay is going to decrease. My asymptote is y equals my k value. And my k value is the number at the end of the function. Notice that we have a positive 4. Plus 4 is positive. So my asymptote is at y equals positive 4. So on the y-axis at positive 4, you guys will make your asymptote horizontal line, and you make a dashed line to tell people that is your asymptote. So that is my asymptote, and I need to graph my function using 2 points. Now notice that we do have a transformation. Let me just label the number 4 as k as well here, so you guys know that is your transformation. Your transformation says that the k value is positive 4. So your parent function, the one with no transformation, you move that up 4 steps. So whatever those points are, and we're going to plot those points, we're going to find those 2 points. I'm going to have to translate, which is move up 4 steps on the coordinate plane. Now my a value in front of the parentheses, which is the base, we have an invisible 1. So we don't have to worry about the a value, and it's positive. So there's not a lot to say about the a value, but we do have a transformation of 4 steps up. So how do we find the points? First of all, I ignore the k value. I don't use the k. I just use y equals a times b to the x power. Now remember, a is your invisible 1. We do not need that invisible 1. And also remember that f of x is the same thing as y. So I can change that to y equals 1/3 parentheses to the x power. So my 2 points, I'm going to use a 0 for the x and a 1 for the x on the second point. I'm going to substitute those into the x, the 0 and the 1, and I'm going to find the y value. So I'm going to use 0 for the x. Any number to the 0 power is 1. So that's my first y value, 1. And the next one, x equals 1. So 1/3 to the first power is just 1/3. So I'm going to put 1/3 right there. So that's not my actual graph. Remember that we have a transformation, but I'm using those points as a reference points, so I know what points to move 4 steps up, which is the k value. That's your transformation. So let's go ahead and plot those points from the origin. 0, 1 is right here. You see it on the screen. And 1 and 1/3, 1 to the right, and 1/3 up. It's just a little bit up from the x-axis. So you're just going to estimate. I'm going to say right there is my second point. Do not connect those points because I have to transform. I'm going to move those 2 points 4 steps up. So I'm going to use this point first. From here, I go up 1, 2, 3, 4. So I have a new point up here. And the next one here, remember that this is 1/3 up. So I have to move one step, but a little bit higher than the regular one here. So because it is 1/3. So I go one step up, 2 steps, 3, and 4. So it's going to be a little bit higher than the asymptote right there. Now you guys are going to make your actual graph. So I'm going to start up here. I'm going to go down and I make my curve. It is exponential decay because I do have my base less than 1. So notice less than 1 here. 1/3 is less than 1. And I have a transformation. I move the parent function. Those 2 points represent the parent function. Now for your y-intercept. Now notice here that when you guys move the actual graph, the y-intercept is not 0, 1 anymore because I have to transform that parent function, which is going to change the y-intercept. So same thing as before, you guys will substitute a 0 into the original function and into the x. So x, you guys will let x equal to 0. So I'm going to put here 0, and I need to find the y value. So I'm going to take f of x and change it to y equals 1/3 to the 0 power plus 4. So I simplified the expression. 1/3 to the 0 power is just 1. Any number to the 0 power is 1. And you guys will have plus 4. So y equals 1 plus 4 is 5. So my y-intercept is at 0, 5. And once again, you guys can confirm with the graph, it is crossing a positive 5. The domain will be all real numbers. And that's for your exponential functions. You guys, domain works. The x values work for any exponential function, all real numbers. Now the range is where the asymptote comes in. So notice that my graph is on top of the asymptote. So I have to use the inequality of greater than. So I'm going to use y is greater than, and I need to look at the k value. And the k value is 4, which is the number at the end of the function. So my range is y is greater than 4. And the last one I'm going to show you guys is when you actually have a negative a value. I'm not going to make it too complicated with you guys. I'm not going to give you guys k or h here. I just want you I want you to understand what the negative does to the graph, and that is called a reflection across the x-axis. So same thing as before, you guys need to know if it's exponential growth or decay. Now don't get confused because this negative means that the a value is -1. So let me just rewrite this again so you guys can see the a value with the negative. So f of x is going to equal -1 times 2 to the x exponent or the x power. So notice that I separated the -1 from the 2. So my base is actually 2, not -2. And that's where students get confused because when they see the negative, they say, oh, -2 is less than 1. Well, no, you guys need to understand the negative is for the a value, -1. My base is the number with the exponent, it's just a number, ignore the sign. And the number in this case is 2. That's going to be greater than 1. So I'm going to put it here, I'm going to highlight it, and I'm going to write b is greater than 1, which is your base. And that means you guys have exponential growth. So I know the direction of the graph. It's going to go from left to right, and it's going to increase. But there's a transformation. So that's where you also have to understand. The negative, so you guys have a negative a value, that's going to be a reflection across the x-axis, which means it's going to flip the graph upside down. But let's take this step by step. For now, ignore the negative. I just want to find the asymptote. So the asymptote is the same thing as before. I need to find my k value. And my k value in this function is 0. You guys can look at this one too. It's the same function. We have no k value. So y equals 0 for my k value. And let me just label that k value at 0. So I'm going to graph my asymptote. Since it's 0, it's on the x-axis. It crosses the origin. and I make a dashed line because I need to know that is my asymptote. My next step is to find 2 points. Now, remember that when you guys have a transformation, I tell you guys to ignore the k or the h, but in Algebra 1 we don't use h. You guys will see that in Algebra 2. I am going to use the a value and the base, just those two. So I will have my negative with the 2. So I'm going to have y equals negative 2 to the x power. Now you also have to be careful with the signs because it makes a big difference when you have a parenthesis and the negative is inside or if it's outside. So here we don't have parentheses, so we don't have to worry about too much, but you also have to remember what happens with the negative, okay? So the 2 points. The 2 points, I will use 0 for my x and 1 for my x on my second point. I am going to substitute 0 into the x here. So I'm going to do this step by step. Y equals negative 2 to the 0 power. Now remember that I mentioned that you have to be careful when you have a parenthesis or no parenthesis. Since we don't have a parenthesis here, I need to keep my negative that's in front of the 2. I just bring it down. And I'm going to simplify 2 to the 0 power. And 2 to the 0 power right here is just 1, but I do have that negative. So my first point is at 0, negative 1. So let me just zoom in here so I can have a little bit more space. We have a negative 1. So I'm going to plot that point. 0, negative 1 is right there. My second point is when I substitute a 1 into the x. So I have y equals negative 2 to the first power. So since I don't have parentheses, I need to bring down the negative. I need to simplify 2 to the first power, and that's just 2. So my negative 2 is my y value, negative 2. So 1, negative 2 is right here. All right, now let's make sense of the problem. I need to connect the points, but remember that I mentioned the negative a value tells you to make a reflection across the x-axis. If you guys do not have a negative in front of the 2, let me just give you guys the graph, the direction of the graph when there's no negative. If there was no negative, your graph would go from left to right, increasing like this. Okay, now notice that I'm not using a real color there. I'm just highlighting the direction because that's not the actual answer. That's not the graph that we want. I'm going to flip. I'm going to make a reflection over the x-axis, across the x-axis, on the other side of the x-axis. So this graph, when you guys flip it upside down, you will have the graph really close the asymptote, and you're going to go down like this. Now, notice that I say down. It's not exponential decay because the parent function, if you guys do not have a negative, it's actually exponential growth. What this tells you is that you guys have a reflection across the x-axis. So it is exponential growth because the base is more than 1, it's 2, but it's a reflection over the x-axis, or you guys can say across the x-axis. The definition of the asymptote is the same. The graphs will never touch the asymptote, so don't try to connect the asymptote with the graph. But you guys have to be careful with the domain, especially with the range, when the graph is below the asymptote. Now let's go ahead and find the y-intercept. The y-intercept is when you guys substitute a 0 into the original function. So I'm going to have y equals negative 2 to the 0 power. That's going to be your y-intercept, and I need to find the y. So y equals, you keep the negative because you don't have a parenthesis, and 2 to the 0 power is 1. So my y-intercept is at 0, negative 1. You guys can confirm with the graph. Remember, the orange curve is the graph, not the purple highlighter there. That's just the parent function. That doesn't have a transformation. So your transformation is across the x-axis. It's flipped over the x-axis. So my y-intercept is 0, -1. My domain, no matter if you guys have a transformation or a reflection across the x-axis, domain is always the same. My domain is all real numbers. Where you guys have to be careful is the range. The range depends on where is the graph depending on the asymptote. So my asymptote is on top of the x-axis and the graph is below. Notice the orange one. Again, not the highlighted one. That's just the original parent function. We're looking at the orange one. So this is below the asymptote. So first of all, I need to use y is less than because it's below the y, below the asymptote. So I need to use less than, and I need the k value, and the k value is 0. So I'm going to put 0 right there. So my range is y is less than 0. So let me tell you guys, explain that, what it means. So since the graph is below, every y value of the graph will be negative. Notice it's below the 0, the asymptote. So it's going to be -1, -2, -2.5, -3.9, -4.5, and all the way to -infinity. So that's what the range means. Because it's below the asymptote, it's less than 0. Domain is all real numbers. You guys see the y-intercept. And keep in mind that even though you guys have a negative in front of the 2, your a value is negative. Your base is 2. Since it's bigger than 1, it's exponential growth. Even if you guys have a fraction, of -1/3, your a value is -1 and your base is 1/3. So 1/3 is less than 1, that's going to be exponential decay. So just be careful with those numbers, and just the way you guys can learn how to graph the exponential functions is by practicing. And last thing I'm going to show you guys is to determine whether the set of data shown below displays an exponential behavior. So we want to know if it's yes, it is exponential behavior, exponential growth or decay, or maybe no, it's not exponential behavior. So this is what it means, okay? When you guys have a table, notice I'm going to go to the first table here. You guys have the x values. The x values is 0, 1, 2, 3. The y value is 3, 9, 27, 81. Remember that before you guys have something called arithmetic sequences. You guys are adding the same number to get to the next one on the y values. So here you might be thinking, okay, I might be adding to get to the next number. Well, guess what? 3 plus 6 is 9, but 9 plus 6 is not 27. So you guys are not adding. Exponential behavior is when you guys are multiplying to get to the next y value. So this 3, I have to check if I have to multiply by a number to get to the next one. So if I multiply 3 times 3, that's going to be 9. And if I multiply 9 times 3, that's going to be 27. And if I multiply 27 times 3, that's going to be 81. So guess what? Since you are multiplying the y values by 3 and it's the same every time, then we say, yes, this is an exponential behavior. So looking at the next one, since now you know what to look for, you just look at the y values and you check if you have to multiply by a number. So only the y values. The x values, you guys are going to be increasing constantly, which means the same, but on the y value you have to multiply. So if you guys multiply 1 times, now this is decimals, so I'm going to use decimals, 1 times 0.5, that is going to be 0.5. And if you multiply 0 times 0.5, that's going to be 0.25. And if you multiply 0.25 times 0.5, guess what? It is going to equal 0.125. Now this is using a calculator, but you guys are multiplying by the same number every time. So what this is telling you, the table is representing an exponential behavior. Now the last one, notice the y values. The x values, they're increasing constantly, so you have -1, 0, 1, 2, 3. But the main thing is the y values. They're all the same. you guys have 3, 3, 3, 3, 3. Now you guys can say, well, you guys can multiply by -1 and -1. But guess what? When you guys have the same value on the y, that means that it's not an exponential behavior. Even though you guys are multiplying by 1, 3 times 1 is 3, 3 times 1 is 3, 3 times 1 is 3, it doesn't represent an exponential behavior. If you guys actually graph the points, you will see that the shape will not be a curve. It's actually going to be a line. So that's going to be a linear function. So this represents a linear function because the y values are all the same. So this is not an exponential behavior. Exponential behavior. So now you guys know what to look for in a table to understand if it's an exponential behavior or exponential function or not an exponential function. So this is the end of my second video for exponential functions, guys. I want you guys to practice so you guys understand the asymptote and the domain and range. If you guys like my videos, you can always hit that like button. You can also subscribe so you guys can know when I have new videos on my channel. Make sure you guys practice, and I'll see you guys later.